is bridges. Okay. But in case of buildings, what we have seen is there is a shortening of the column due to which additional forces on the beams may occur. So due to that, failure may occur in the beams or columns. Okay. So that is why column shortening is needed. And this effect is basically seen more in the high-rise buildings because the load is very high in case of high-rise building. That's why shortening is more. In low-rise building, this effect can be neglected. Okay. But yes, it is there. Okay. So in order to account this, like during the construction stages, we need to account the dead load in the sequential format. And then we also, if in case if you are dealing with concrete structures, you may be aware that concrete is concrete material is basically time-dependent material. Like the elastic modulus, creep and shrinkage is changes with the time. So we need to account all those things. Okay, we'll discuss how we'll account this in the software. But yes, these are the things which we have to take care. Okay. So importance of construction stage can also be seen in this basically in this picture. Okay. So during the if we are like spanning the long span trusses over here, you can see the final support position at these two locations. Okay. But during the erection, you have pulled this trusses at this point. Okay. So during the erection, the support position is this, right? So when you analyze this particular trusses in this erection position, the force distribution will be totally different. And in that situation, there might be a criteria in which maybe this beam will be failing. Okay. So that is why construction stage analysis is very necessary during the erection. If you want to analyze the structure during the erection process. Okay. So this is just an example. Okay. In this, yeah. So let us understand what makes a difference when you doing the conventional analysis and the construction stage analysis. Okay. So in this figure, you can see in the conventional analysis, what we do is we just make the whole structure. This is a two-story building, let us say, and all whatever the loads that are coming, we'll apply directly. Okay. And the construction stage, what we do is first the first floor will be casted or whatever the construction process you are doing in the actual site. You'll model that similar thing in the software, and then you'll apply the loads sequentially. Okay. Then in the second floor, when second floor is activated, then we will apply the load of the second floor, which is dead load or some other loads. Okay. So in this way, we have to do a construction stage analysis. Okay. So in this scenario, in this particular model, I notice that if you do the conventional analysis, the force, the demand of the bending moment at the middle of the beam of the first floor is around 29.2 kilonewton meter. But when we do construction stage analysis, it has been 32.3. So you can see if you design this particular beam, considering only this particular value, which is 29.2, you may like miss this value. So during the construction itself, your building will going to fail, like the beam will going to fail. Okay. So that is why it is necessary to account the construction stage analysis. Okay. So let us understand this like numerically, what is happening, why the forces are basically different. Okay. So in this figure, you can see the conventional analysis where superimposition principle is valid. So what we do is, like this is a whole structure which has been casted. We apply the load on the first floor, and then second we apply the load in the second floor, and we just club the result. So the result which we get around 29, it's the result of these two. Okay, numerically. And in the stage of construction stage, what we do is in this stage two, you can see stage two of this and this is same. But the stage one, in this stage one, the first floor is not activated. So the stiffness of the whole structure is totally different. So that is why there is a difference in the results. So when we club these two results, we get a value around like 32, which we seen before in the previous slides, right? Okay. So this is what construction stage. If you miss construction stage, this might be an adverse effect will be there. Okay. So after that, we just understand now the column shortening. Okay. So we know that if we apply a load on any column, so the shortening will be around like PL by A. So similar thing happens in the columns as well. So whenever you apply this loads over here on the building, it directly the shortening will be the elastic shortening will be PL by A. Okay. So right now I'm just considering the elastic shortening only. Okay. So suppose this is one of the building over here. Okay. In this building, uh, there will be like if you consider these two columns, so the load resisted by this column will be of the area of this, let us say, and the load resisted by this column, which will be having this square region, which is more than this column area, right? So obviously this the load carried by the interior columns will be more. So we see the shortening formula, which is PL by AE, which is directly dependent upon the P. So obviously, the shortening in this interior column will be more. Okay. So due to this, what happens is my beam, which the beam which I have casted in the original position, it will be inclined like this because interior column is having short height. So due to this inclination, there will be additional moments. Uh, uh, like additional moments will be there. Okay. So what we can do is we can design the building considering the construction stages, and then we will consider this additional moment for design as well. So in this way, the beams will be safe. Okay. So um, so this in this way, differential shortening can be happen between the column. And now if we also consider like creep and shrinkage shortening, due to that, in the case of like concrete structure, it will be also providing the shortenings. Okay. So if you see over here, like in the steel structures in which like 80-story building, there is shortening of 180 mm to 255 mm can be happen. Okay. In case of concrete structure, it is limited to 65 mm. So the total shortening will be around like 180 to 230 mm. And elastic shortening is basically limited to 1 to 3 times of the elastic shortening. Okay. Now, in case of Lotte World Tower, what happens is if you consider like elastic shortening. So elastic shortening is basically when the shortening is in the elastic region, and in elastic deformation, which will be including the deformation due to the creep and shrinkage. Okay, so you can see when I in this Lotte World Tower, we have a core wall and the main column. So in this, we can see there is a difference between these two. Uh, like shortening. In this shortening, there is a difference. So this is what is happening, column shortening. Okay. So due to this, there is a vertical deformation in the building as well as horizontal deformation in the building. Okay. So we need to take care of these two during the analysis as well as in the construction. Okay. So let us see how we'll. So first of all, let us discuss more about the types of shortening which maybe happens. So in case of steel structures, there is basically a linear elastic behavior. Okay. So only like elastic shortening is only there in case of steel structures. So directly, like you can do the shortening analysis of this steel building by hand also, because only like PL by A is there. So we can do this. But in case of concrete structure, the non-linear inelastic shortening is also present. So that is why we have to do the shortening analysis in the softwares. Okay. So you can see this in the concrete structure, the shortening will be elastic shortening plus inelastic shortening, which is elastic strain and inelastic strain. Okay. And the total strain will be considering all the shortening, which is elastic strain, creep strain, and shrinkage strain. Okay. So this creep and shrinkage property, basically of the concrete, are dependent on the material properties and conditions of the geometry of the member. So what is the size of the member basically? As you can see, the amount of creep will also depend on the proportion of the ingredient which you are using, like in the concrete. and condition under which it has been constructed. Okay, so the relative humidity of the construction site will also play a major role in the shortenings, in the elastic shortening. Okay, and finally, one of the factor which only affect grip is the age of loading. Okay, so all these things we have to monitor during the construction of the building. Okay, now how to account this all like creep and shrinkage property in the software. So in order to account this, we have a time dependent material property referring to various codes. Okay, so if you see this Euro code, ACI code, CBFIP is very popular. Okay, CBFIP code is there. Okay, but like all these tests which we do in the labs. So basically, these all results are the results of labs only. Okay, but in labs, what we consider is only the concrete is considered for the testing, right? But when you construct the building, there is also a rebar. So due to this rebar, there is a like creep and shrinkage effect is somewhat different. Okay, so in order to account that, we can also go for the PCA method, which will also account the effect of the rebar in the concrete during the column shortening. So that is also a very good option. Okay. Now, what are the adverse effect which column shortening causes? So, as I said, like the beams which will be like in the inclined position, it will be having the additional forces, and then we will design those buildings for the additional forces. That is the concern. Okay. Other than that, it will also have a structural effects, which is like distortion of the slab or beam or the walls which are there. Okay, it may distort that, and also it will also have the adverse effect on the non-structural element. So basically deformation and breakage of the facade, windows or parapet walls, or deformation of the vertical piping system which you provide. So due to this, failure may happen in these systems as well. Okay, so now how to correct this? Like if you are dealing with the construction, how during the construction, if you see, first thing is for the beams or the walls, I will just give the additional, due to this additional moment that has been generated in the beams. I will design those particular beams for them. Okay. Other than that, if you want to safeguard your this non-structural elements, okay, you have to give the correction at the site. Okay, during the construction. So what you will do is, in which, suppose this is a interior column, or in case of our problem, which is Lotte World Tower, there is a core wall and the main columns. Okay, so in this case, what we'll do is we'll just rise the level of the column by some value, which is called as correction. Okay, correction for the column shortening at the each level. So each level, I will increase the height of the column such that the final stage is perfectly horizontal. Okay, so these correction we have to calculate inside the software based upon the column shortening results. Okay, now for this shortening, we also have like two types of shortening, again based upon the construction. Okay, which is like pre-slab installation and post-slab installation. Okay, which is in the name itself you can understand, just before casting the slab, there is a shortening which is called as pre-slab, and after the casting of slab, it will be called as a post-slab. Okay, so in case of reinforced concrete structures, the pre-slab shortening is not like not important, because what happens in the site, if you see, what people will do is, if there is a shortened column is present, they will just increase the formwork to that particular level, such that all the columns will be on the same side. Okay, so pre-installation, the pre-slab installation shortening is not necessary. But in case of steel structures, it is very necessary, because what we in the columns we see in this steel structure is, it is fabricated along the exact length. So so that is why if the length has been shortened, in case of this pre-installation also, the shortening is to be calculated, and it has to be account in the corrections as well. Okay. Now let us understand the whole process of this column shortening analysis. Okay. So first of all, what we do is we'll do the pre-analysis in which the whole building is been modeled in the software, and we will account the column like the time-dependent material property based upon the codes, like whatever the codes like ECI, Eurocode, or SEV, FIP, or any other method. Okay, we account the creep and shrinkage, and we calculate the shortening. Okay, and whatever the additional force which we get in the beams, we will design them as per the additional forces. Okay, and as per the schedule, like the contractor will decide if he wants to go, like they will see the shortening values and all, and they will decide if they wants to do the correction at the site or not. The correction which I showed you in the previous slides, right? We have to increase the height of the columns like that. In some project, the the engineer has to decide they have to go for the correction or not. Okay, so in this particular Lotte World tower, they went for the correction. So, okay. So what is the process uh, of this correction? So first of all, during the construction period, up to like before the construction period, they have to decide from where they are going to opt the all the materials which are going to be used for the construction of the building. So based upon that, up to some certain period of time, like after the pre-analysis. So already I have done all the designs, everything is done. Okay, the construction is going to just started, and I am going to collect all the materials at the labs, which I'm going to use for the construction. So based upon the time which has given to us, we have to do the testing. So in this particular Lotte World Tower, we have given like 6 months prior to the construction time. Okay, so all the materials again has been tested. Okay, tested for like creep and shrinkage and compressive strength, everything. Okay, and then according to this property, there will be some difference in the creep and shrinkage and everything, which we have already predicted according to the various codes. Okay, so we have to update those values over here, and then again we have to run the analysis. Okay, the column shortening analysis, and again we have to give the like calculate the shortening, and then again we have to calculate the corrections. Okay, then after that the construction will start. Okay, and during the construction he'll apply some strain gauges, load gauges, and everything will apply. Okay, and then we also note what is happening in the actual site. Okay, suppose you give the column shortening, column should be shortened by 20 mm. Okay, but the column is shortened by 25 mm. So in that scenario, we have to update the model over here in the first, second, three reanalysis. We at each stage, like we'll define the specific stages. Okay, like every 5 floor we will apply these corrections over here from the site like that, and after that again we will remail re like again we will make the model, and then again run the analysis, and again whatever the shortening is coming, again we will provide the corrections, like modified corrections to the site. So in this way the whole process will be continued during the construction. Okay, so like we just understand like how column shortening is done actually in the software as well as in the site, on the site, like when we are doing the corrections and all. Okay, so now let us talk about the how this has been implemented in the Lotte World Tower. Okay, so the Lotte World Tower is located in the Jamsil, Seoul, South Korea. Okay, and basically the height of the building is 56 meters. Okay, and the number of floors is basically 123. uh, Okay, and the function is basically, as you see over here, there are various hotels are there, office buildings are there, and like premium offices, observation levels are also there. I have been this tower. The view is very good from this point, observation level, which is situated at the 497.6 meter. Basically, when they announced the construction of this is the highest observation deck in the world. So what Burj Khalifa did is they wanted to be highest in the number, so they increase. They have an observatory level in maybe around like four. 450 meters. So they just increase it to the 500, more than 500 meters. Again, one of the observatory they added. So in this, after that, if you see, they have like foundation type as a matte foundation. And if you see in this figure, this is the core walls which has been constructed. Okay, and these are the main columns over here. And over here, this is the outrigger trusses that has been constructed. Okay, and the construction period was in between like 2011 to 2015. Okay, this is again the actual picture of the construction site. So you can see like this is the core walls and the main columns. It has been constructed. Okay. So during the pre-analysis of this tower, what they have noticed is the horizontal deformation prediction was around like in the x direction 27.2 mm, in y direction it is 115.5 mm. Okay, and we have to provide the safety checks for the elevator and the vertical pipes. Okay, and there was also a differential settlement in the foundation as well, which is like 35 mm in core walls and columns, which is around 16 mm. Okay, talking about the vertical deformation at the top of the tower, it was like in the steel frame, it is like 368.7, and in the core wall, 314 mm. Okay, and similarly at the top of the mega column as well. And they have noticed the differential shortening on the column, like steel column, which is like maximum was 55 mm. So this is the shortening between the core wall and the main column. Okay, and the mega column, it was around 65 mm. Okay, so this was done in the pre-analysis. Then they collected the site, and according to this pre-analysis, they have suggested this particular correction at each floor level. Okay, so these are the floor levels you can see, and each floor level they have defined the correction. So if you see at the basement to the level 3, when the level 3 is constructed, they have given the correction for the core wall as design level, which has been decided, plus 3 mm. And for the core wall, it is like whatever the core level will be there, plus 5 mm for the main columns. Okay, so like this data has to be generated for each and every level. So like I said, we not necessary at each level we have to provide this correction. There we have to define the intermediate locations at which we will be providing this shortening. Okay. Now I will do this material testing. Okay. So this uh, ana this analysis software, Midas Gen, has been used for doing this column sorting analysis. And after studying all the material and updating the model according to the material properties of the site, and the testing was done for the 6 months, as I said, we have noticed that there is a reduction of the 32 to 33% in the creep deformation and shrinkage deformation, which we have predicted. Okay. So accordingly, again, I will just update the model. Okay. And the design period, the relative humidity basically was a 61.4%. So we have to update that as well, which has been considered for average for 5 years. Okay. And target period of the shortening for safety verification is taken as 100 years. And for the service period, it is taken for the 33 years. Okay. So, like, is there any questions we will take at the last? Okay. So during the pre and like you can see this is the variation in between like the pre-analysis and the re-analysis, which has been taken after the material testing. Okay. So these are the difference you can see. You can see the reduction in the shrinkage and the creep. Okay. Now, after the reanalysis, again, the results has been given for this B6 level to L 75 levels. The settlement was noted as in the mega column was 1 to 25 mm. Okay. And the core walls, it was like around 23 to 29 mm. Okay. And the maximum shortening of the mega column was noted as like 133 mm, which is basically 80 to 83% of the pre-analysis. Okay. Then shortening on the of the core walls was around like 74 0.1 in the level 71. Okay. And the differential shortening is noted as 53 to 60 mm at level 65. Okay. And again, above the level 76 to L106, these are the shortening after the reanalysis. Okay. So these are the shortening values. And again, the differential shortening was noted as 40 to 44 mm at the level 76. Okay. Now, how we are measuring this actually, like the whatever the shortening which we got. So we installed various load cells, level surveying, and strain gauges in the buildings. These are the locations of these strain gauges which we installed at the intermediate level. So basically, we installed in total 12 floors. Okay, this loads, this strain gauges. Okay, in core walls, basically 10 device per floors. Okay, and these are the like locations of this strain gauges which has been installed. Okay, and the mega column, we have installed like 40 devices per floors. Okay, so this is how we like uh, apply these strain gauges in the mega columns, in the core walls, and internal core walls as well. Okay. Now, after that, after the reanalysis, these are the shortenings which software we provided. So we didn't provide the shortening into up to this point because up to this point construction has been done. Okay. After that, we can see now again the correction has been applied to each level. Okay. These are the corrections which we provide like design level plus 20 mm for the core wall, then for the column design level plus 20 mm. So these are the, again, now this process has to be done rigorously after each intermediate floor which we have decided. Okay. Now, like this is up to the column shortening, but other than that, they also have some issues related to the outriggers. Okay, outrigger trusses which they install. So what happens is on this outrigger stresses during the constructions, they have very much high stresses. Okay, so what they did is they provide a delay joint. Okay, so due to this delay joint, these stresses was reduced very much. Okay, and this same thing has been modeled inside the software itself, and they have noted that there is a sufficiently release in these stresses due to this delay joint. And after the construction, the whole construction process, okay, construction process. The for the slabs they are designed for this additional stresses due to the column shortening. They designed them as well. Okay, in the software itself, and as well as to prevent the damage and elimination of the curtain wall due to the differential shortening among the columns, we provide some gap between them. Okay, so the curtain wall or the glass which we provide some gaps. So due to this, so we have to give these shortening values to the fabricators. They will accordingly give the proper gap and fill the some material between those gaps. Okay, which is like filler material. And this is the model which has been created in Midas Gen software of this Lotte World tower. Okay, so the whole construction sequence has been modeled, and this construction sequence has been decided uh, like uh, uh, before the construction itself. Okay, but sometimes what happens is there is due to some limitation or some accidents or some reasons, this construction stage may not be there actually on the site. So we have to update the model again. According to that, again, same story goes on. Okay. So this is the particularly the model which has been done in Midas Gen. Okay. You can see slowly all the things, core walls, the mega columns, everything has been constructed. Okay. And after that, the above truss, outrigger trusses will be modeled. Okay. Now the accidents which I was talking about in this Lotte World also, that's due to some reasons the core wall schedule was delayed for the 172 days, and again the mega column schedule is also delayed for the 36 days. So due to this, again we have to update the model. Okay. And then again we have to do this column shortening and all, and then again whatever the changes in the results we have to update. So basically these are the comparison between the pre-analysis which we have done, and after that updating this schedule, we have noted this these are the like shortening in the core walls. Okay. And the columns. Okay. Now, the next part is useful features for Midas Gen in terms of high-rise structures. So, first of all, we'll talk about the construction stage itself. Okay. So, for modeling the construction stages, basically we provide automatic generation of these construction stages with the wizards. Okay. So we just need to enter the sequence of the loading which are coming, and then automatically software will model the construction stages. And after the modeling, you'll also get this column shortening graphs. Okay. This column shortening graph will be up to the cast level and subsequent to the cast level. Both type of results will get. Okay. And also in terms of construction stages, if you are dealing with composite columns, okay. So these two, if you see this composite column I section has been the concrete section, has to be activated into the two different stages. So through this composite section for construction stages, we can activate them into the different construction stages, and the exact composite action between these two material can be seen inside the software. Okay. Then again, like in terms of high-rise structures, yes, we consider these scale section stiffness scale factors, right? So to reduce the stiffness of the section in order to capture the cracked crack property of the concrete. Okay. So we can provide the section stiffness scale factor. Okay. And through the use of this boundary change assignment, basically we can use this reduced stiffness for the specific analysis in the same model. Okay. So basically in all the softwares, we have to generate various other models, but here through this use of this boundary change assignment in the same model, you can go for the reduced stiffness for the specific sections in the specific analysis itself. Okay. Then we can also define like various types of nonlinear supports in the software of the piles or raft. Okay. We can give like distributed springs or nodal springs. Okay. So we just need to enter the data related to the soil and like pile over here, and automatically the spring stiffness will be generated. Okay. And these are the analysis types which Midas Gen can handle, basically almost like all types of stat from conventional analysis to nonlinear analysis, all types of analysis Midas Gen can handle. So you can see like response spectrum, time history, P delta, buckling, heat of hydration, construction stages, pushover, or like other analysis like moving load settlement, uh, or a boundary nonlinear time history analysis, which we can do. Okay. After the analysis, basically in case of high-rise structures, what happens is we have to provide the various checks in the building, which is like story drift check or a story displacement check or a mode shape check. Okay. So based upon the IS code, which is like 1893 and 16700, which is a code for high-rise structures, we can check this all these checks. Okay, like torsional irregularity check, weight irregularity check, or story shear force ratio as well. Okay, and as far as design is concerned, we can generate the load combination based upon IS 800, and we can design the concrete structures as well as we can do the ductile detailing for them. And the steel frame design is also available, and the ductile detailing for the same is also present, which is being the code has been released in 2023, and it is already implemented inside the software. Okay, then we can do slab in the same software. Okay, isolated footings we can do with the design plus, and optimization of these all sections can also be done inside the software. Okay, the basement wall and shear walls, and after the design we will get this kind of summary report as well as the detailed report as well. So in this, detailed calculations will be there. Okay, and in the month of June recently we have implemented this many updates for the Indian users specifically. Okay, so various types of irregularity checks as per 1893 16700 has been implemented, and then like various updates in these like 18168, the ductile detailing code for the steel, as well as in the upcoming version we are going to implement the new code, which is IS 1893 new code, which is in the draft position RAM, but we're going to implement that as soon as final version has been released, and many more updates for the Indian users are going to be updated as soon as possible. Okay, thank you. And this is my email ID, anmol@midasit.com. If you have any queries in the future, you can just mail me or Nikhil Jadhav. This is the Nikhil Jadhav's ID and his phone number. Okay, so you can contact us at any point of time. And now I'm open for the Q&A, so you can ask whatever the doubts you have.
Thank you very much, Anmol sir.
Yeah.
I request the students or the faculty to please post your questions in the chat box. I also request everyone, all the participants, to please fill out the feedback form. So, any questions?
Saxena sir, namaste sir.
Yes, sir.
Hello.
Namaste. Yes,
Now
sir.
I have a small doubt
Yeah.
regarding the use of software, because for our
Mhm.
civil engineering department we run structural engineering program for
Mhm.
MTech students, and
Yes, sir.
also for BTech students we have purchased the software like ETAB, then StatPro, and there was a discussion regarding which is the latest software that can be used for analysis and design of such multi-story structures or high-rise structures.
Yes, yes.
So like Midas or the, as I just mentioned, maybe ANSYS, or so there was a little discussion that which software need to be purchased so that we can take care of all such things in the future. This thing.
Okay.
So will you guide us in this regard?
Actually, yeah, in the past, if you see, if you see our project applications, basically all like high-rise buildings in the Southeast Asia, or maybe like if you see the Burj Khalifa, the skyscraper also,
Yes,
these are
yes.
all designed in Midas Gen itself. So you can consider Midas Gen for your like internal like
Okay.
training, and like if you want to do yourself also, it will be very helpful. In case of
Okay.
research projects also, we provide
Yes.
like detailed time history analysis over here,
Okay.
in which like various types of non-linear analysis is also there. And
Okay.
yes, like it will be helpful. But yes, also like not only Midas Gen, like
Yes.
various we can see FENX also. This is also
Okay.
very advanced nonlinear tool, which will be helpful in the research purpose also as well.
And what is your opinion to make use of this StatPro ETAB software?
Okay,
Shall we go
basically,
with that?
yeah, yes, sir. Like basically, choice is yours. But I can say in this Midas Gen, we club all the things which has been present in both ETAPS and STAD. Okay,
Okay.
the modeling
Okay.
type is basically as STAD. So if you're dealing with stat basically, so modeling type is same. So you don't have that much issue in modeling.
Okay.
Okay, and all the results like story based results which we get in apps, we will get
Okay.
here also. And in addition to that, various types of irregularity checks and all everything is there. So
Okay. Okay.
all, yeah, so it is very helpful, I think so.
And now a little different question now from my side. That would be last question.
Yeah.
Uh, Now we heard a lot of about the Burj Khalifa, which was got constructed in 2010 or so,
Hmm.
and it is a 829-meter high building and having 166 floors. And
Yes.
it is learned that this building sways in horizontal direction by 1.25 meter on either side of the central line. So
Okay.
similar to this that building is this building your Lotte building has got
Hmm.
sway in horizontal direction.
I think that I have to check because in
Okay,
terms of final results,
okay,
I don't have any values right now.
okay,
But
okay,
initially, due to they have predicted some values, like
okay.
if you see, I have showed one slide in which like
Yes,
they have
yes.
predicted due to this shortening, there will be this much vertical and horizontal
Displacement
difference.
that was this about
Yeah,
the displacement. Yes.
yeah. That will be going to happen. But
Okay.
they have considered this. That shortening, that deflection, maybe happened due to some other reasons as well. We have to check in the Burj Khalifa.
Yes, yes. Thank you so much, sir. Thank you so.
Thank you.
And it was a very
Uh,
nice session from your side.
Thank you,
Thank you
sir.
very much, sir. Anmol, sir, I have a question.
Yes.
You spoke something about pre-analysis and reanalysis.
Yes.
So I just want pre-analysis and then reanalysis, like you were calibrating your models and you were again
Yes.
like doing the reanalysis. I just
Yes.
wanted to know how many times like did you have had to do this reanalysis and rerun the whole model? Like, what was it?
Actually, yes. So based upon the your like construction site, you have to decide. So in this site, you can see at the 12 floor levels, we have installed these strain gauges. So based
Okay.
upon these, you can decide, okay, 12 times I will update the model. Okay. Or sometimes if you feel like the shortening is very high in one of the column, then again you can apply the corrections and like update the model.
Yes. So it was basically you were acquiring the data from the site during the construction, and
Yes.
then you were recalibrating your model, and then
Yes.
the whole process was like was the whole design changed in a sense, or like
No, no, no.
just the like the this
Shortening,
thing like
shortenings only will be changing. Design we
okay,
already done with the pre-analysis, what we get.
okay,
Okay. This is only for the shortening, basically.
shortening, and then the like
Updating the mod.
the correction like
Yes, the
which was
correction.
necessary.
Yes,
Yes, yes,
yes,
sir.
yes.
We have one
Because
more question.
yes, yes.
It's from Saurabh Patil. He's a student, I guess. So he asks, Sir, suppose if software suggests some amount of shortening of column, and in actual, if there is a difference between the values, like value, just I'll read it out
Okay. So he's asking like if we
more or
predicted
less. Yeah.
suppose 20 mm and the
Yes,
shortening is 25 mm suppose. So how we will deal with these values? So
yes.
basically, yes, again we have to update the model which we have prepared for the pre-analysis, and we have to update in such a case that it got shortened by the 25 mm exactly in the software itself. Then again we will apply the corrections in the site for the above stories, like that. So
So it
again
was
and
the
again,
same question, I guess. Yes,
yeah,
it
yeah,
was continuation of the same question about reanalysis and then doing it
yes,
again and again.
yes.
Thank you very much, Saurabh. I hope like your doubt is cleared. Is
Patil
there
sir.
anyone else?
I
Yes,
think
sir.
Savita Patil madam raised the hand.
Yes.
I
Madam, would
maybe
you
I
like to
missed it.
ask the question? Savita Patil madam.
Sir, we have also shared feedback form in the
Yes.
chat box. Please fill the feedback form in the meantime.
Nikhil Jadhav sir has shared the feedback form. Uh, all are requested to please fill the feedback form. Yeah, I guess there
Amit
are
sir,
no more. Yes, sir. Yes, sir.
Amit sir, I have
Yes, sir.
copied this link and I have shared with you on WhatsApp.
Yes, sir. I have shared it with all
We
the
will have to
students.
circulate
Yes,
it
sir.
among us all our
Yes, sir.
students and
Yes, sir.
faculties.
We'll do it. I have the link with
Yes,
me.
Yes, sir. Also share in the your alumni group where all
yes,
the
yes,
yes.
sir. Yes, sure, sure.
Yes, sir. We'll share it. Yes, sir. Thank you. So I guess all the questions are finished. Like, shall we end this session like
Yes, sir.
with the permission of the? Yes,
Yes,
thank you.
sir.
Uh,
Sir, we would also like to introduce Midas Gen to RIT also. It is very
yeah,
prominent institute in the Maharashtra, and we would like to collaborate with you also as well. It is just starting off for collaboration. In the future also, we will provide so if any kind of
And
support is required.
yeah, we can arrange this kind of sessions as well for students, and
Yes,
yeah, we can prepare some industry oriented topics as well.
yes,
Yeah.
sure, sir.
sure.
Uh, in this regard, we will contact you from civil engineering department. We will formally contact you in this
Yeah.
regard, and
Yes,
then we'll see how it can be taken forward.
yes, and if
With this,
yes.
yes, yes,
Yes, sir.
yes, sir.
And if any consultants or are in the meeting for commercial discussion, you can call me on the number on the screen. I will also share my details with like already Abhishek Kale sir have my details.
Yes,
You
yes.
can take details from me, and we can have a meeting in your office also.
Yes, sir. Yes, sir. We will invite you, sir.
Yes, yes.
Definitely
Okay.
will invite you.
Yes. Thank you very much, sir, for the
Thank you.
opportunity.
Thank you for a nice session. And we will try to collaborate with you or interact with you on some other issues also
Yes, sir.
related to our structural engineering program and
Yeah.
civil
Yes,
engineering
yes.
program. Thank you
we
so
can
much.
So
also
I,
even we can also even help in like your research oriented work.
Yeah.
We
Okay.
can
Yeah.
give
Yes, sir.
we can give our inputs, like we have the team of technical support engineers,
Yes.
basically in our Mumbai office we have a team of technical support engineers.
Okay.
So from the Mumbai office only we provide support to all the English speaking countries like
Okay.
America, Europe, South Asia, Egypt, and Africa, and Middle East, and India. Yes,
Okay,
Australia
sir.
also. Yeah.
Okay.
Yes.
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 Thank
Thank
you
you very
for
much for
inviting
your
us
time.
in
Nikhil
this
sir.
session.
Yes. I'll
Yes, sir.
just quickly
Nikhil sir.
give a formal vote of thanks. I thank Mr. Anmol Saxena and Mr. Nikhil Jadhav for presenting the topic case study of column shortening analysis of Lotte World Tower, South Korea in 119 progress meeting of RA. On behalf of Civil Engineering Department, RIT Rajaram Nagar, also I would like to extend my heartfelt thanks to both the speakers. We will make sure that the collaboration between RIT and of course the Midas IT will continue forward, in this regard. I thank all the core members of RAH for taking active efforts and presenting such kind of sessions. I thank all the faculty of Civil Engineering Department. A special thanks to all the alumni who are present here. And last but not least, I would like to thank the students of Civil Engineering Department from BTech and MTech for their presence at such time and then attending this session.
All the
With
deans,
this,
sir, all the deans,
yes, sir.
HODs,
Yes, sir. All the
all the
deans,
faculty members
HODs,
who have.
and all the faculty members of RIT, I also thank them for attending this session. Uh, Thank you very much.
Thank you, Mirza sir. Thank you, Abba Kali sir.
Yes, sir.
Thank you,
Thank
sir.
you. Thank you. Thank you.
Thank you.
Nikhil sir, one
Yes,
request
sir.
from my side.
Yes, sir.
In the next semester, we are offering internships for the students. So, if
Okay.
any possibility in your organization, you can just
Yes, sir.
connect
I
with
will discuss
Patil sir.
regarding this with our director, and I will let you know, sir. Yes.
Okay.
Yes, sir.
Thank you. Thank you very much, one and
Thank
all.
you. Yes.
Thank you, sir.
Good night.
Bye.
Good
Good
night.
night.
Good
Good night.
night.
Thank you.
Good
Yeah,
night.
good
Good
night.
night. Thank
Happy
you.
weekend.
Yes.
Thank you.
Bye. Thank you, Anmol.
Bye bye.
Bye.
Nikhil and Anmol sir. Actually,
Yes,
we
sir.
have very good alumni network. So on social
Yes, sir.
media, we are on LinkedIn, Facebook,
Yes.
Instagram, and around
Okay.
7 to 8,000 people on WhatsApp. So we will
Okay.
circulate your message. Okay,
Yes, sir.
no
Actually,
worries.
sir, I can also share one brochure with you. Uh, you can circulate
Yeah,
that
yeah,
as well.
surely.
Yes.
Yes,
Sir,
yes, yes.
I will take your number from Abasab Kale, sir. Or you can send me message on
Yeah,
this
yes,
number.
sure.
Yes.
Yes.
Okay, thank you very much.
Thank you, everyone.
Thank you, sir. Yes.
Thank you. Bye bye.
Thank you. Bye.